Now I would like to discuss sampling technique in this session. Sampling technique is a process of identifying samples. There are number of techniques to identify samples. We have a detailed discussion on how to identify samples from a sample frame. Here we discuss the process of sampling. Under process of sampling, the first step is define population, then develop a sampling frame, then select sampling technique, then determine sample size and execute the sampling process. Defining the population means population includes complete item of the universe, which further divided into target population and survey population. Survey population is otherwise known as a sampling frame. So therefore, we can discuss all those things in the next stage. Then a third one is a sampling technique. That is our major concern in this session. There are a number of techniques to identify samples that we will discuss later on. Then determine a sample size. A sample size is, in order to determine sample size, there are no hard and fast rule, but practically there is some methods. Certain rules of thumbs are there. In machine using or in computer using technology, you can get certain sites that exclusively for sample size calculation, like SurveyMonkey is an example for that. Then finally we have to execute the process of sampling, that is the actual selection of the sample is called execution of the sampling process. Here we have a discussion on what is population, what is survey population and samples. Target population is the overall items that included in the research. That is, it is a population for which the results of the research is required. Entire items of the population is included in the target population. We cannot get information from all the items of the target population. Therefore, for survey purposes, we further divide the population into a small part which is called a survey population. Survey population, it is otherwise known as sample population or sample frame. It is not the complete population but a part of the target population. For example, if we discuss the socio-economic status of the unorganized workers in Kerala, target population is the entire employees that comes under the unorganized sectors. But while selecting sample, we cannot depend all the sectors. Instead, we take one or two sectors from the unorganized sector, like let us take casual laborers and employees work in construction sector. Therefore, these two employees, the group of these two employees constitute a survey population from which we actually drawn our samples. Therefore, survey population is that population from which we actually drawn our sample. Then sample is only a part of the survey population, but the sample should be a representation of the complete population. These are the difference between target population, survey population and sample. Here we have moved into sampling techniques. There are number of sampling techniques. The technique through which we are identifying samples are called sampling technique, and it is broadly categorized into two. One is probability sampling and another one is non-probability sampling. Probability sampling is otherwise called a random sampling, in which each items of the sample frame has equal chance of being selected. That means the selection is purely random and every item of the frame has equal chance of being selected. That is why it is called random sampling or probability sampling. At the same time, non-probability sampling is selection is purely by the judgment or intention of the researcher. That is why it is called a non-probability or non-random. That is, selection is purely influenced by the researcher himself. That is why it is referred as non-probability sampling. The given figure will explain probability and non-probability sampling. The first figure shows random sampling, in which the selected items are represented by the blue dots. The blue dots are scattered here and there. That means there is no clear pattern, and researcher has no influence on the selection. That is why the selection is scattered all over the sampling frame. And the second figure shows the probability sampling, in which again the selection is represented by the blue dots, which shows a clear pattern. That means the researcher selected deliberately each item, so that he systematically selected the items. These are the difference between probability sampling and non-probability sampling. We have a detailed discussion on probability sampling. Probability sampling is a sampling technique in which each member of or each element of the sampling frame has equal chance of being selected, and the selection is purely random. Purely random means on the basis of probability. Therefore, there is no distinction between one item and another item. All item has equal chance of being selected. There are different types of random sampling, which is there are 5 types of random sampling is there. One is simple random sampling, second one is stratified random sampling, third one is systematic sampling, fourth one is cluster sampling, and finally multi-stage sampling. Simple random sampling, it's the simplest form of the random sampling, in which all the members of the universe has equal chance of being selected. For example, if there is a population is 50 numbers, and if one has to select only one sample, then the probability for each item is 1 by 50. That is called a simple random. That means the complete sample frame is considered as a single pool, and there is no distinction between items. This type of sampling can be suitable for homogeneous population. If there is heterogeneous population, we cannot use simple random sampling, because it do not distinguish between items. Therefore, if there is a heterogeneous population, still the selection may be skewed towards a single items. Therefore, simple random sampling, while applying simple random sampling, the condition is the population must be homogeneous, and all the elements in the population have equal chance of being selected. And the simple random sampling also divided into 2. One is without replacement, and another one is with replacement. Without replacement means a unit has only one chance of being selected, is called a simple random sampling without replacement. With replacement means an element can get more than one chance of being selected. That is called simple random sampling with replacement. These are the 2 types of simple random sampling. The figure explains how the simple random sampling occurs. There is no distinction. The whole population considered as a pool, and selection is made by 2 methods are for selection. One is lottery method, and another one is table random numbers. Lottery method means a blindfold selection, that in which each item give a particular number, and we made a lot and mixes all the lots within a container, and a blindfold selection is made. That is called a lottery method. And another method is called a table random method. There is inbuilt random tables are there. One example is Tippett's table. From the table numbers are randomly placed. Therefore, we select particular items on the basis of the table, which is called table random numbers. And nowadays, computer also used for selection of the simple random, that is simply an Excel sheet can be used for selection of samples. These are the method to identify simple random selection. Next method is stratified random sampling. It is a method that has more advantage than that of simple random sampling. It is a complex random sampling method in which we can also use heterogeneous population. First of all, what we do is the total population is classified into different groups of homogeneous nature. That means if population has heterogeneous nature, then we classify the total population into homogeneous groups. And after homogeneous groups, from each groups we are selecting the required number of samples. That is called a stratified random sample. That is, the selection is purely random, like the selection as we select in the case of simple random sampling. That means after the only difference is we make the total population into different groups. From each groups, the selection is made either by random tables or by a lottery method. That is called stratified sampling method. Stratified sampling method also has two methods. One is proportionate stratified sampling and another one is disproportionate stratified sampling. Proportionate stratified method means for each class the sample are selected proportionately, which is called a proportionate method. Disproportionate method means we are disproportionately selecting from different classes, means we are giving more importance for certain classes and less importance for other classes. This is called a disproportionate method. For example, if our population is 1000, from which we have to select 200 samples of unorganized sector employees, then we have two sectors. One is casual workers and another sector is called construction workers. From each sector you can get a male employees as well as female employees. Therefore, we have four classes. There is casual male workers, casual female workers, construction male workers and construction female workers. These are four classes. From each classes you have to select same proportion of employees. This is called a proportionate selection. Sometimes in the construction employees, male workers are around 90% and female workers are merely 10%. In that case, if you select a proportionate selection of 100 samples, you get 90 numbers of male workers and 10 numbers of female workers. Sometimes it may be underrepresentation of the female workers. In such a case, what we do is we disproportionate the selection, in which we select 20% of the female workers, so that we can get 20 numbers of the female workers and 80 numbers of the male workers. This is the difference between proportionate selection and disproportionate selection. However, under stratified sampling, we are using the sampling for heterogeneous population. Another method is called systematic sampling, in which elements are selected systematically. Only one item of the sampling frame is selected randomly and all other items are selected at a regular intervals. Such a sampling is called systematic sampling. In order to identify the regular intervals, we can use an equation k equals n divided by n. K represents interval and n, capital letter N is the population size and small letter n represent the sample size. By dividing population size by sample size, you get a class interval of the, or in regular interval of the sample selection. Okay. For example, if we have 1000 number of population from which you have to select 100 samples, then our regular interval will be 1000 divided by 100, which will give 10. Therefore, we arrange the total 1000 samples or items in a regular manner, and each 10 are A class. 1 to 10 is first class, then 10 to 20 next class, and so on. From the first interval, we made a random sample selection. That means we make a lot of 10 numbers and it mixes in a jar and select one with a random selection or lottery method. For example, if you get to the fifth one, then 5 is your first sample. Then next sample is find out by adding regular interval with the first element. That is 5 plus 10 will give second element, that is 15. Then 15 plus 10 will give next item, and so on. That is called systematic sampling. That means if our first element is n1, then n2 equals n1 plus k. Then n3 equals n2 plus k, and so on. This is called systematic sampling. The systematic sampling can be well explained with the figure given in the slide. Next one is cluster sampling. Cluster sampling means we are separating the total population into different groups. The peculiarity of the group is the groups are homogeneous, whereas within the group the items are heterogeneous. Such groups are called clusters. The clusters or groups are made on the basis of age, sex, region, and the like. We randomly select certain clusters and completely avoid certain other clusters, and enumerate the items within the clusters completely. This is the process of cluster sampling. Therefore, random selection is not the items but the clusters. That is the basic difference between stratified sampling and cluster sampling. Under stratified sampling, we take each and every classes, and we select items within the class randomly. But in this case, we take only limited clusters. We do not select all the clusters. Only if we have 5 clusters, from which we are taking 2-3 clusters and avoid the rest. And within the clusters, we enumerate complete items. That is called cluster sampling. If the cluster is based on the regional classification, then such cluster sampling is also known as area sampling. And cluster sampling again divided into 2. One is single stage cluster sampling, and another one is 2-stage cluster sampling. The single stage cluster sampling is described with the first figure in the slide, which shows that out of the 5 clusters we are selecting 1, 4 and 5th clusters. Then we enumerate complete items within these 3 selected clusters is called single stage cluster sampling. Under 2-stage cluster sampling is represented by the second figure, in which again we select 3 clusters, 1, 4 and 5th clusters, and we completely avoid second and third cluster. Then under 2-stage clustering, again within the cluster we made a sample selections, a random selection of the sampling, and that particular samples only taken as for analysis. That is called 2-stage clustering. This is the part of cluster sampling. Next one is multi-stage sampling. Multi-stage sampling is the combination of one or more methods we already discussed. Is called multi-stage sampling. Here in different stages of sampling we are using different samples. That means in the first stage we may classify into different clusters. Then from clusters we constitute different strata. Then again from strata we identified different households, and that way we are proceeding with. Such a sampling is called multi-stage sampling. Multi-stage sampling also explained with the help of the figure. In the figure we can see from the population we identified 1 to 10 clusters. Then from each clusters there are homogeneous clusters which are stratified in the next stage. That is, among the 10 clusters, 1, 5 and 9 is homogeneous, therefore it constitutes the first strata. Then 2 and 6 is the second strata, 4 and 8 is the third strata, and 3, 7 and 10 is the fourth strata. Then from each stratum we again made a random selection. That from the first strata we select 1 and 9. From second we select 6, then third, fourth one, and then fourth cluster we select 7 and 10. Then from these strata again we select a household selection. This is called multi-stage sampling. Thus we have 5 types of random sampling techniques are there. We start with the simple random sampling, then stratified sampling, then systematic sampling, cluster sampling, and multi-stage sampling. These are the different random sampling methods we discussed. Now we move into the second type of sampling, which is called a non-probability sampling or non-random sampling. Here the selection is purely up to the researcher. The researcher deliberately select the sample, therefore the base of selection is not random. Therefore there is chance for bias in the selection of samples. There are different methods for selection of non-probability sampling. One is convenience sampling, the second one is purposive sampling, third one is quota sampling, and fourth one is referral or snowball sampling. First we discuss convenience sampling. Convenience sampling means the sample selection is convenient to the researcher or the data collector. That means convenience means it is easy to collect information from the samples. Therefore, the researcher may select that samples who will provide the information very easily. Sometimes he may select that samples who voluntarily ready to provide information. One important example for the convenience sampling is accidental sampling. Under accidental sampling, we are selecting those samples whom we met accidentally. Certain survey conducted by the TV channels are of these types. Sometimes we need to identify the purchasing mechanism or purchasing level of the individuals from a mall. Then we have to visit the mall and select those who are already present in that mall and discussing with them or questioning with them. That is called convenience sampling or accidental sampling, which is a type of convenience sampling. Simply we can call it as convenience means according to the convenience of the researcher we select those who give easily the information. That is called convenience sampling. Then another type of sampling is called purposive sampling, which is also known as judgment sampling, which also purposefully select the researcher. Means the researcher feels that a certain item can provide information more comprehensively, so that he can select certain items. This is called purposive selection or judgment selection. Judgment, he judge that a certain item can provide information very well, so that he can select certain items. This is called purposive selection. Then another one is called quota sampling. Quota sampling is the counterpart of the stratified sampling in the random sampling. Under stratified sampling, we make each of the items into different homogeneous groups. Similarly, in quota sampling, the heterogeneous population is made into different classes. Then from each classes we put a quota. We made a quota, then we select. The selection is not random, but it is non-random selection. The quota is selected in a purely non-random, like purposive or convenience manner. That is the difference between stratified sampling and quota sampling. And the last one is called snowball sampling or referral sampling. Here the selection is especially for those problems in which the problem keeps certain secrecy. Therefore, the items are not revealed themselves. Therefore, we proceed from one sample to another sample, which is called snowball sampling. That means if you get one sample of the peculiar nature, from that sample you make a rapport with that sample. With that rapport, that particular sample will refer next item, and so on we proceed with. That is called snowball sampling or referral sampling. For example, if you conduct a survey on AIDS patients, then patients are not voluntarily reveal their nature. Therefore, if you get one of the AIDS patient, then you conduct a survey with him, and you made a rapport or a friendship with him. With his friendship, he can refer further samples. With then from next samples you can get another sample, and so on. That means we are proceeding from initial sample to further samples. Such a method is called snowball sampling or referral sampling. Here we have a figure that explains all the non-random samples. The first figure shows convenience sample, in which the researcher selects the nearby samples which is most convenient to him, which clears the figure clears what is convenience sampling. The second one is another type of convenience sampling, which is called voluntary response sample, in which the items are voluntarily ready to respond with the researcher, which is another type of convenience sampling. And a third one is purposive sampling, in which the researcher purposefully or judgmentally selects certain items. That item he feels like the items can give complete or comprehensive information. Therefore, he judgmentally or purposefully select the items, which is called purposive sampling. And the last one is called snowball sampling, in which the researcher moves to one sample. From that sample he moves into another sample, and so on. And that is called snowball sampling. Thus, we are discussing total probability and non-probability sampling. Under non-probability sampling, we have 4 techniques. One is convenience sampling, second one is purposive sampling, a third one is quota sampling, and last one is snowball sampling. Thanks.